Welcome back. In this video, we are going to discuss a few things that are continuations of last week's video on object orientation. Because we're not going to be testing certain concepts, so other things will be readings, but I'll explain to you briefly what you're expected to read about that. But first, we discuss inheritance, extremely important concept. When you're creating an object that has a set of attributes, it's important to avoid replication or duplication. So object orientation allows you to have what you call inheritance. For example, let's say you have two objects called student and farmer. All right. In this object, you're going to have first name, last name as attributes, etc. Many other parameters that a student can have. And not so surprisingly, in this object also, in this class, you're likely going to have those things too, because a farmer is a person. So at such times, you need to be able to factorize, we call it, which means you need to be able to decide what are the things that are common to these two classes and make it into one separate class. So in my head now, I'm thinking, either you're a student, you're a staff, you're a farmer, or whatever you are, you're first a person. So what we can do is to create a class called a person and put all of these things in there, then now make these other classes to inherit person. Then for students, we only put unique things that are particular to students. What is particular to students? Student number, for example. Student number is particular to a student. What else is particular to a student? Maybe department. So those will then be they will constitute the only attributes that the student class is going to have. The farmer class can also have other attributes that are peculiar to the farmer. All right. Farm address, for example. Category of crops. etc. All right. So now, if I don't need to give a farmer a first name, a student a last name. I can just make these two classes to inherit this class called person that describes any kind of person in the world. First name, last name, probably date of birth, probably place of birth, whatever you want to include in this class, you can include it. So I want to show you a demo of a class that is called student, that is inheriting another class called person, and a few methods between them and how you can navigate these things. Because it's going to help your design greatly. Object-oriented design is a whole complete topic of its own, and it's quite robust. So in this module, sometimes it's a whole module. In my time, object-oriented design was an entire module. So in this module, we'll not be able to cover everything, but I can show you an example and you can read up, and then you can have a deeper understanding of how to design your objects and how to use those objects in your code. That's it. So I'm going to jump straight into the piece of code. Then I'll come to the reading later on to discuss this. But for now, I'm jumping straight to this demo, and I'm going to be showing things that are very similar to this example I just gave. But this example here, I will remove it. All right. Give it a second. Okay, we are here. All right, I told you in this example that we're looking at student and person. Person can have attributes that cut across any kind of person. However, student should have specific attributes. So let's look at attributes first. If I go to person, again, first name, last name, they are public. Why? Because I want them to be accessible in other classes and other contexts. String, because that's the data type. First name is a string. And public, date of birth. So I call it DOB. And as you can see, the type is a class. It's not just another string like this one's. That's why the color is slightly different. And it says DateTime. So DateTime class is, you can, as well as you can imagine, a string is a literal. It's easy to store in a data type. However, for a date, you need to be precisely specified. It's a composite variable, meaning there is day, there is month, there is year in that date. Sometimes there is time in it. So I'll show you an example of how you can pass that into string or from string into that. So long story short, this is your person class here. Remember to make it public because you can run into errors if it's not public. Remember to make all the attributes that you want to be accessible public. Remember to add more methods if you want methods here, methods. But because this example is not targeted towards a person, the target is more to show you how a student class can inherit a person class. So I won't spend much time here. However, this is your person class. As you can see also, it's in a separate file over here, person file. So then I can go ahead and create a student class. For a student class, I tried to show you a variety of what is possible. A student needs a student number. Not every person in the world needs that. So you can have him, so you can initialize the initial, you can specify what the initial student number is going to be. So in this case, if I don't specify, it's going to be empty. But in this case, I decided to put a string, a literal called not assigned. And you're going to see why that works fine. Department, it's going to be empty if we create a new object from this class that does not have a departmental field that's completed. Modules, as you can see, I turned that into an array of strings because, of course, a module is not just one parameter. Address, of course, that's just a string to say where the address of the student is. And I decided to have an example of a method in this class. Remember, in the person class, we only had attributes, and that was it. I said to you, you can put more methods there if you choose. However, in the student class, because the concentration of this example is on the student class, I want to show you an example of a method that reads in a fresh student every time. This method goes to the console and then reads in a student for each attribute of a student and then stores it in an object of a student and returns the object back. So let's see. It's static because I want to make reference to it anyway. It's probably because I want it to be available. And the type is student. That's going to return type is student. Then the name of the method is read student. As you might have guessed, the new student we need to read, we have to create an object to store the student in. So we call that object S. It's of type of the class student. It's a new object, so we say new student. And we read all the fields one after the other. We read the first name from the console. We refer to that new object. We assign the attribute first name to whatever the user enters. The last name, the same thing. Address, the same thing. However, when it comes to date of birth, we are expecting the user to enter something like this. 5th of May of the year 2020, for example, with the slashes. And this thing as it is now cannot be stored in the data type DateTime. So this data type, think of it like a data type, but it's a class of its own. With time, when you play with object orientation in C#, you're going to understand deeper. But now we need to show you how you can get going, because in a module, programming is a lifetime thing. You don't get to learn everything in a module. So this, as you can see, is a construct. It's a struct. We call it a struct. It's called DateTime. But the symbol we have integer.pass, int.pass, double.pass. You can pass whatever string the person enters, which you have to remember the person has to enter a sensible string. If it's not sensible, we have to be able to track the error, which is a different topic entirely. However, we're going to assume the person enters a date that is similar to the date I just showed you here. When it's entered, we convert that into a date time, then we store it inside this attribute. This attribute is of type DateTime. If you hover the mouse, you can see it. DateTime, it's in a person class, and it's a DOB. Now, when all these parameters are entered, how many attributes have we filled up in the read student? 1, 2, 3, 4. Do not forget that the student inherits the person class. So this is the part I'm getting into. So I would have said this class is your student. All right. In that case, I'm going to have errors saying to me student class does not have a first name, student class does not have a last name, and in fact does not have a date of birth. So if I go back to person class, I realize those are the classes that have these things. So in order to inherit these things from the person class, for obviously the reasons I told you about before, I put full colon and then I specify the class that is being inherited. So in programming, we call this class the superclass and we call this one the subclass. All right. So and immediately everything looks perfectly okay now. What this class means is public class student. What this means is this is a student class. However, it inherits a person class. Every variable, every attribute, and every method in this person class can now be used in the student class. And that's pretty straightforward. And I was just showing you examples of that. Example is that the student class now can use first name, I can use last name, and these attributes are not in the student class. As you can see, they are only available in the person class, as you can see. So that said, read student, we didn't know all these attributes and we return S. The question is, have we read all the attributes? Maybe not. Let's go back and check. Date of birth, we read that. First name, last name, we read that. Go to student class, we check more attributes. Department, we did not read that. All right. So it's going to assume it to be empty, and an empty string is an empty literal. Modules is an array. It's going to assume it to be empty. An address, I think we read address, so address is fine. Then we did not read student number. However, we initialize the value to be not assigned. So if we attempt to display a new object called student, after reading a student in, we are expected to see not assigned because every other thing in that attribute would have been assigned except a student number, and this is supposed to be empty because it was also not assigned. So, guys, that is basically what we have in inheritance, but I'm going to now go back to the main program to show you an example. So the main program, what am I trying to do? I want to just demonstrate how all of these things come into one picture. Display student is a method I've created like the ones you created last week that can display different attributes of a student. So first, full name, I want it to be, because it takes an object called student S. As you can see, it's of type student. If I decide to turn this to person, you could see, you might realize that there's some errors. Why? Because first name is available in a person, last name is there, however, student number is not available in a person, so it's going to give you that error. So, but in this case, I just want to display student. So student, everything looks fine. First name is not available in the student, but the student class inherits the person class. So we're good. So it displays the first name and the last name as full name, concatenated with just an empty literal in between. Student number is displayed. Don't forget that we did not read in the student number. So in this sense, you're expecting to see something like not assigned. Year of birth is displayed as a sub-attribute of the DOB. So I explained to you that the DOB is a construct, it's a structure. And it's almost like attributes of a class. So a DOB itself gives you date, time, year, many other attributes of a date. But if I click dot from that point, I can see methods that are available for me in the DateTime class. I can keep scrolling down. I can even add minutes to the date. I can add months. I can add second, add ticks of the clock. I can extract the actual date itself. But what I wanted to display in this sense is just the year. So it's one of the attributes. So I want you to play around and see all of the attributes that are in this DOB, a DateTime class. In this case, DOB is just an attribute of S, and it still contains those fields from the DateTime class. All right. And this method is supposed to just take a student and display only a few things about the student. Not everything is displayed here. Department is not displayed. Modules are not displayed. So you have to think of your application. Anytime you're writing it, do you want to display everything? You're going to display a few things. All right, that's it. So now let's look at the main program where we get to test all of this. In the main program, I can create a fresh object called student, and it's a new student. Of course, you're familiar with this line now. It's easy. But instead of reading into the student, I have isolated the reading task to a method inside the student class. So in the student class, I created this method called read student, as you can see, this method here, that uses the console, reads everything and stores it in the student object. All right, so it's there. So in my main, instead of having a cumbersome code or source code, I can isolate the reading part to other classes, and that part is called abstraction in object orientation. It's one of the readings I will give to you. Abstraction, meaning you hide, it's called information hiding. You hide things all over the place. Encapsulation is a slightly similar concept, but still different, but then I will ask you guys to read about it. So S now, which is a new object, should now be student class.read student. All right, so it gives me all of the students in the student class. Another thing I could do is to pretend like my S is not a new object and just declare an object called student and allow it to go straight into that class to read. What is the difference? In the first scenario, which is this one, this object is new, meaning that it's created as a new instance. Don't forget, an object is an instance of a class. It's new, meaning that I can assign new attributes to it. However, in the second example I gave to you, where I just said student, let me put it side by side so that you can see it. Let me call this student S1 equals, and I can just say, go to the student class dot read a student with that method there. The difference is that this object right now is not a new object. All right, so I may not reassign the attributes of this object. And I'm okay with that because this method already does creation of a new object for me. So if I go to this method called student, as you can see, it creates a new object, read student, and sends it back. All right, so I may not worry about that. So either way in this context works, and it's a matter of preference. However, you might run into problems where you're trying to assign attributes and it's not going through. It's because your object is not a new object. So you might consider using this technique more than this one. So I'm going to remove this one. Again, with time, you're going to see all of the differences as you play around. So I read this new student from the student class. Display student is another method that I've created, and I've shown you that we don't have to display everything, and everything gets displayed, and that's it. Fantastic example for inheritance. And I will run this so that you can see. It's coming up. Okay, so it says enter first name. I'm going to enter myself because I like myself, obviously. Adebijola. And address, I'll say number 20, Programming Streets, and Dev Avenue. All right. City, let's call it C# City. All right. Date of birth. Now I need to put something that looks like a date so that the pass function can work fine. So I'll just put 2nd of February. I'm not born in February anyway, but yeah, it's good as an example. Of the year, I'm going to pretend like I'm a lot younger now. So I'm going to say 2001, like most of you guys are. 2001. Okay. Now, immediately, I was done striking the last. So this was me reading all of those things. When I strike enter, then I was on this method that says display student. As you can see, full name now says Adebijola, which combines that with that. Student number is displayed, but it says not assigned. Explain that to you because the object of student was initialized. The default value was not assigned, and we did not change the value, so hence it remains. And we did not display the address. As you can see, the display only displayed full name, student number, and that. And year of birth, even though we collected a whole date, we displayed .year of the year of birth. So that pretty much shows you quite a number of things that you can play around with. And I'm going to go back here to show you the things you have to read up on because we're not going to be assessing these things, so it's fruitless to spend time on them. I'd like you to check out the difference between abstraction and encapsulation. For your knowledge sake, it's good to know. Polymorphism is another thing. Polymorphism is having different methods that or objects that may be in different classes, and you want to put them in a space where you can call them regardless of which class they belong to. So that's polymorphism. An example of how you can do that is interfaces in C#. Please, by all means, Google it and kind of read about it. So these constitute your reading. However, we've been able to go through inheritances and see with the student versus person class. All right, assignment. So what I want you guys to do is to think of two classes that one can inherit the other. All right, then you write some functions for these classes, and please play around with these concepts. All right, that's your assignment there. It's ungraded, so please by all means enjoy it. And before I end this video, which I think it's getting into a very long video now, I'm going to just stop by just to clear our Unit 3 up, because I think we're done with Unit 3. Practice. You've seen the practice. We've seen most of the things. We've seen the person class. We've seen the student class. Book class, we saw that last week. Customer class, you can play around with those things. Here are a few demos and abstraction things I've said about abstraction. They're all here. Readings. Okay, let me go back here for a second. So here it says use getters and setters. Please, or by all means, read up about those things. They're also very trivial. You've seen them from last week's lab. Readings. Other things you have to read about: fundamental principles of object orientation. What is object orientation? I told you object-oriented programming and object-oriented design. And in fact, next semester we're going to be looking at object-oriented relational databases. So these are concepts that are a whole topic of its own. So they have many things you may want to read up on. And classes, what's a class? I have some text here for you to read. Object orientation, the whole idea is here for you to read. And I have things around inheritances, abstraction, encapsulation, and polymorphism. These three are part of your readings. This one I've shown you an example. Polymorphism, I've also kind of told you what that's all about. I'm not going to be giving you labs that have those things now, so it's kind of like a reading that you have to do on your side. And here I've also put text to kind of give you like a simple definition of these things. And that marks the end of our Unit 3. I'm back. So we would look at these things. We'll continue from this point next week. This week we're going to have extra labs that discuss more of these concepts with some algorithms or maybe some random numbers or some recursion in the middle of all of this. Good stuff. See you guys on the other side. Boom.